In mathematics and computer programming, the order of operations is a collection of rules that define which procedures to perform first in order to evaluate a given mathematical expression. For example, in mathematics and most computer languages, multiplication precedes addition. Thus, in the expression 2 plus 3 times 4, the answer is 14. Brackets, or, which have their own rules, can indicate an alternate order or reinforce the default order to avoid confusion. Thus, the preceding expression could be changed to times 4 to produce 20, or 2 plus to produce 14. Since the introduction of modern algebraic notation, multiplication has taken precedence over addition. Thus 3 plus 4 times 5 equals 4 times 5 plus 3 equals 23. When exponents were first introduced in the 16th and 17th centuries, exponents took precedence over both addition and multiplication and could be placed only as a superscript to the right of their base. Thus 3 plus 52 equals 28 and 3 times 52 equals 75. To change the order of operations, originally a vinculum was used. Today, parentheses or brackets are used to explicitly denote precedence by grouping parts of an expression that should be evaluated first, thus resulting in times 4 equals 20 to force addition to precede multiplication, or 2 equals 64 to force addition to precede exponentiation. Definition: the order of operations used throughout mathematics, science, technology and many computer programming languages is expressed here. Exponents and roots, multiplication and division, addition and subtraction. This means that if a mathematical expression is preceded by one binary operator and followed by another, the operator higher on the list should be applied first. The commutative and associative laws of addition and multiplication allow adding terms in any order, and multiplying factors in any order, but mixed operations must obey the standard order of operations. It is helpful to treat division as multiplication by the reciprocal and subtraction as addition of the opposite. Thus 3/4 equals 3 divided by 4 equals 3 1/4. In other words, the quotient of 3 and 4 equals the product of 3 and 1/4. Also 3 minus 4 equals 3 plus. In other words, the difference of 3 and 4 equals the sum of positive 3 and negative 4. Thus, 1 minus 3 plus 7 can be thought of as the sum of 1, negative 3, and 7, and add in any order. Plus 7 equals minus 2 plus 7 equals 5, and in reverse order plus 1 equals 4 plus 1 equals 5, always keeping the negative sign with the 3. The root symbol, square root, requires a symbol of grouping around the radicand. The usual symbol of grouping is a bar over the radicand. Other functions use parentheses around the input to avoid ambiguity. The parentheses are sometimes omitted if the input is a monomial. Thus, sin x equals sin, but sin x plus y equals sin plus y, because x plus y is not a monomial. Some calculators and programming languages require parentheses around function inputs, some do not. Stacked exponents are applied from the top down, i.e., from right to left. Symbols of grouping can be used to override the usual order of operations. Grouped symbols can be treated as a single expression. Symbols of grouping can be removed using the associative and distributive laws. Also, they can be removed if the expression inside the symbol of grouping is sufficiently simplified so no ambiguity results from their removal. Examples: a horizontal fractional line also acts as a symbol of grouping. For ease in reading, other grouping symbols such as braces, sometimes called curly braces, or brackets, sometimes called square brackets, are often used along with parentheses. For example, exceptions: there exist differing conventions concerning the unary operator minus. In written or printed mathematics, the expression minus 32 is interpreted to mean 0 minus equals minus 9, but in some applications and programming languages, notably Microsoft Office Excel and the programming language BC, unary operators have a higher priority than binary operators, that is, The unary minus has higher precedence than exponentiation, so in those languages minus 32 will be interpreted as 2 equals 9. This does not apply to the binary minus operator minus, for example, while the formulas equals minus 2 squared and equals 0 plus minus 2 squared return 4 in Microsoft Excel. The formula equals 0 to 2 squared returns minus 4. In cases where there is the possibility that the notation might be misinterpreted, a binary minus operation can be enforced by explicitly specifying a leading 0, or parentheses can be used to clarify the intended meaning. Similarly, there can be ambiguity in the use of the slash symbol in expressions such as 1/2 x. If one rewrites this expression as 1 divided by 2 times x and then interprets the division symbol as indicating multiplication by the reciprocal, this becomes, with this interpretation, 1/2 x is equal to x. However, in some of the academic literature, implied multiplication is interpreted as having higher precedence than division, so that 1/2 x equals 1, not x. For example, the manuscript submission instructions for the Physical Review journals state that multiplication is of higher precedence than division with a slash, and this is also the convention observed in prominent physics textbooks such as the course of Theoretical Physics by Landau and Lifshitz and the Feynman Lectures on Physics. Wool from Alpha changed in early 2013 to treat implied multiplication the same as explicit multiplication. Formerly, implied multiplication without parentheses was assumed to bind more strongly than explicit multiplication. 2x, 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 and 2/2 now all yield x2. Newer Texas Instruments calculators also yield x2 in all 3 cases. Mnemonics. Mnemonics are often used to help students remember the rules, but the rules taught by the use of acronyms can be misleading. In the United States, the acronym PEMDAS is common. It stands for parentheses, exponents, multiplication, division, addition, subtraction. PEMDAS is often expanded to, "Please excuse my dear Aunt Sally," with the first letter of each word creating the acronym PEMDAS. Canada uses BEDMAS, standing for brackets, exponents, division, multiplication, addition, subtraction. Most common in the UK and Australia are BODMAS and BIDMAS. In some English-speaking countries, parentheses may be called brackets, or symbols of inclusion, and exponents may be called either indices, powers or orders, which have the same precedence as roots or radicals. Since multiplication and division are of equal precedence, M and D are often interchanged, leading to such acronyms as BOMDAS. The original order of operations in most countries was BODMAS, which stands for brackets, orders, division, multiplication, addition, subtraction. This mnemonic was common until exponentials were added into the mnemonic. These mnemonics may be misleading when written in this way, especially if the user is not aware that multiplication and division are of equal precedence, as are addition and subtraction. Using any of the above rules in the order addition first, subtraction afterward, would also give the wrong answer to the problem. The correct answer is 9. The best way to understand a combination of addition and subtraction is to think of the subtraction as addition of a negative number. In this case, the problem can be seen as the sum of positive 10, negative 3, and positive 2. To emphasize that addition and subtraction have the same precedence, the mnemonic is sometimes written PEMDAS, or simply as PMA. All of these acronyms conflate two different ideas, operations on the one hand and symbols of grouping on the other, which can lead to confusion. Special cases. If exponentiation is indicated by stacked symbols, the usual rule is to work from the top down, because exponentiation is right associative in mathematics thus, which typically is not equal to. However, some computer systems may resolve the ambiguous expression differently. For example, Microsoft Office Excel evaluates a caret B caret C as caret C. which is opposite of normally accepted convention of top-down order of execution for exponentiation. 4 cubed squared is evaluated to 4096 in Microsoft Excel 2013, the same as squared. The expression for caret, on the other hand, results in 262,144 using the same program. Another difference for the same program is a caret b, which is evaluated as caret b instead of minus. For compatibility, the same behavior is observed on LibreOffice calculators. Different calculators follow different orders of operations. Many simple calculators without a stack implement chain input working left to right without any priority given to different operators, for example giving, while more sophisticated calculators will use a more standard priority, for example giving. The Microsoft Calculator program uses the former in its standard view and the latter in its scientific and programmer views. Chain input expects 2 operands and an operator. When the next operator is pressed, the expression is immediately evaluated and the answer becomes the left hand of the next operator. Advanced calculators allow entry of the whole expression, grouped as necessary, and evaluates only when the user uses the equals sign. Calculators may associate exponents to the left or to the right depending on the model. For example, the expression a caret b caret c on the T92, the TI30XII and the TI30XS multi-view associate 2 different ways. The T92 and the TI30XS multi-view in math print mode associate to the right, that is, a caret b caret c equals a caret equals, whereas the TI30XII and the TI30XS multi-view in classic mode associate to the left, that is, a caret b caret c equals caret c equals. An expression like 1/2 x is interpreted as 1 by T82, but as x by T83 and every other T calculator released since 1996. As well as by all Hewlett-Packard calculators with algebraic notation. While the first interpretation may be expected by some users, only the latter is in agreement with the standard rule that multiplication and division are of equal precedence. So 1/2 x is read 1 divided by 2 and the answer multiplied by x. When the user is unsure how a calculator will interpret an expression, it is a good idea to use parentheses so there is no ambiguity. Calculators that utilize reverse Polish notation, also known as postfix notation, use a stack to enter formulas without the need for parentheses. Programming languages. Many programming languages use precedence levels that conform to the order commonly used in mathematics, though some, such as APL, Smalltalk or Occam, have no operator precedence rules. In addition, because many operators are not associative, the order within any single level is usually defined by grouping left to right so that the 4th of April 16 equals 4 equals 1 rather than 16 equals 16. The logical bitwise operators in C have a precedence level that the creator of the C language considered unsatisfactory. However, many programmers have become accustomed to this order. The relative precedence levels of operators found in many C-style languages are as follows. Examples: A plus, B plus, plus plus A plus B plus, A plus B asterisk C A plus, A, B and C A, and B equals C A and B equals C A and. Source-to-source compilers that compile to multiple languages need to explicitly deal with the issue of different order of operations across languages. HAX, for example, standardizes the order and enforces it by inserting brackets where it is appropriate. The accuracy of software developer knowledge about binary operator precedence has been found to closely follow their frequency of occurrence in source code.